Look around you. Everything you rely on, your fastest internet connection, the newest computer chip, even life-saving medicine, was built here on Earth. But the next generation of absolutely essential, world-changing products can only be made in one place. That place is 400 kilometers straight up in low orbit, utilizing ZeroG manufacturing. The simple truth is, the factory of the future is not on Earth. For decades, gravity has been holding us back, forcing us to build our most advanced materials imperfectly. We're going to trace the line from pharmaceutical breakthroughs to global regulatory chaos, showing you exactly how this industrial power shift controls the global supply chain.
Before we begin, it's important you know why building in space is so beneficial. It all comes down to perfection. When we try to grow a high-value material on Earth, whether it's a protein crystal for a drug or ultra-pure silicon, gravity is the main villain. When you mix materials or let that crystal grow in a solution, gravity causes two major problems you cannot fully stop. Convection, think of boiling water, the hot stuff rises, the cool stuff sinks. This turbulence swirls the material and introduces microscopic defects and impurities into the crystal structure. Sedimentation, gravity pulls everything down, causing the materials to settle and stick to the container walls, again creating imperfections and internal strains. In low Earth orbit, in microgravity, both problems vanish. The liquid stays perfectly still. Molecules move slowly, uniformly. This undisturbed environment allows crystals to form in a state of near-perfect uniformity and purity. The results are not just a little better, they are fundamentally better. We get drugs that work perfectly, glass that transmits data 100 times faster, and computer chips without a single defect. That is the difference between an experiment and a trillion-dollar industry.
So let's find out when ZeroG manufacturing will become a reality.
2030. The space stations launched by companies like Axiom and Starlab complete their crucial first test runs. They are proving once and for all that manufacturing complex materials up here is totally worth the money. They focused on high-stakes products, advanced drugs, and superglass called ZBLAN fiber optics. The data is astonishing. By eliminating gravity's interference, orbital ZBLAN fibers show up to 100 times less signal loss than anything made on the ground. Suddenly, despite the high cost of the rocket ride, the superior quality is generating serious capital. Big pharmaceutical and telecom companies are rushing in. The race for technological advantage has begun, and the starting line is in orbit. 2035. The first orbital manufactured therapeutic, a highly complex drug for a major autoimmune disease, produces wildly successful results in its final human trials. The drug's superior purity and crystalline structure, which is simply impossible on Earth, translates directly to patients seeing higher effectiveness and demonstrably reduced side effects. This single, undeniable success validates low Earth orbit manufacturing not as a scientific curiosity, but as an absolute pharmaceutical necessity. Suddenly, major drug makers are pouring billions into planning their own orbital facilities. They realize that if they want the next generation of medicine, they have to leave Earth. The traditional Earth-based drug discovery model is officially starting to look obsolete.
We proved the science and established the massive economic reward. But that success, fueled by rapid, uncoordinated competition, was about to cause an inevitable collision, not just in the market, but in the orbital environment itself. 2040. The first automated, remotely managed commercial manufacturing module is successfully bolted onto an existing station. It proves that space factories can run 24/7. Success means speed, and dozens more commercial systems rapidly follow. But this sudden explosion of uncrewed commercial assets in LEO overwhelms current traffic control. The increasing risk of catastrophic orbital collisions, what we call the Kessler Syndrome, goes critical.
global powers realize the 1967 Outer Space Treaty is useless for an industrial zone. They are forced into urgent negotiations on a new, binding LEO Industrial Governance Treaty, or LIGT, to handle orbital right-of-way, liability and mandatory cleanup. The very path to industrial success is now choked by the debris of our own ambition. 2048. 8 years after the regulatory crisis, the new treaty has brought order to LEO, and industry is scaling up fast. The Orbital Supply Chain Corporation, a new player, unveils the first truly dedicated ZeroG manufacturing park. Immediately, the global tech giant Synapse Systems moves the manufacturing of a critical component there. This component is the ZeroG processed precursor, hyper-pure semiconductor material. These materials require the near-perfect lattice structure afforded by microgravity to eliminate defects. They become the non-negotiable starting material for all next-generation quantum computing chips and high-frequency military sensors. Suddenly, these orbital factories are producing the single most valuable strategic bottleneck component on Earth. Any disruption to LEO is now an immediate threat to global technological superiority. 2055. ZeroG manufacturing is completely integrated into the global economy, providing a critical supply of advanced products. This industrial maturity is cemented by the final key piece of the puzzle, the widespread deployment of fully reusable mega launch systems. The cost of accessing orbit drops permanently below the $500 per kilogram threshold. This kills the last economic barrier for routine, large-scale cargo transport. The orbital factory environment is now viewed by every investor as a fundamental competitive advantage. Nations start intense tax holiday competition, desperately trying to woo orbital corporations to incorporate within their jurisdiction. Low Earth orbit is no longer the final frontier. It is simply the new high-tech industrial center of the world. The ZeroG revolution is complete. It began with the simple desire for a purer crystal and ended by transforming the global economy. By removing gravity, we did not just make better things, we created a whole new kind of scarcity, a scarcity of Earth-grade perfection. The most valuable products are now made where we least expected them, proving that the future of advanced manufacturing is truly out of this world.